Here in Chapter 2 we begin our work with angles. Angles can be measured in degrees or radians. Here we have two different angles, one measured in degrees with degrees, minutes, and seconds. And here is our angle in decimal form. We need to be able to convert back and forth between the two. So minutes and seconds, just like with time, we're saying that there would be 60 minutes in a degree, 60 seconds in a minute. So we could convert this, if we're going to convert to decimal form, by taking our 9 degrees plus the 9 minutes, that's 9 out of 60, plus the 9 seconds, so that would be 9 out of, as far as minutes compared to degrees, we would have 3,600, 60 times 60, for the seconds to go into our decimal form. This gives us 9.1525 for our decimal form. Now, as far as going from degrees in decimal form into degrees, minutes, seconds, so now we're going to have our 19, and then to change this 99 hundredths into minutes, we would take that 0.99 times 60. That's going to give us 59 minutes, and then we have 0.4 minutes left over there. So we're going to take that 0.4 then times 60 to find out how many seconds that is. That's going to be 24 seconds. So then we still have the original 19 degrees. Then that gives us the 59 minutes and then the 24 seconds. Now, of course, our calculator is going to be able to do all of this. If we have the original, there was 9 minutes, and then 9 out of 60 for our, 9 degrees, and then 9 minutes, and then the seconds, we get the 9.1525 that we mentioned before. Now, as far as going from decimal into degrees, minutes, seconds, we had 19.99, and we have a button. If we hit second angle, go to the angle, and you have the fourth option there is degrees, minutes, seconds. So we're going to take our decimal form and convert it to degrees, minutes, and seconds. And again, we get our 59 minutes, 24 seconds there. Now we're also going to be converting back and forth between radians and degrees. All right, radians, and then we're talking about going around the circle, and it's going to be in terms of pi. And then degrees, of course, to go around the circle is 360 degrees. If we are talking about a negative angle, typically an angle we would measure, we'd go from 0, and to go counterclockwise would be positive. To go clockwise would be considered a negative angle. When we're converting between radians and degrees and radians, if it begins as a negative angle, it stays a negative angle. And when we're converting this, to convert from degrees into radians, then I'm going to multiply by pi over 180, because pi radians is equal to 180 degrees. Now when we multiply that across, of course it's still going to be negative. Our 60 and our 180 would reduce, so we get pi over 3 radians. And then to convert from radians to degrees, I would take the reciprocal there, so we have 180 degrees is equal to pi. And now when we multiply across, the pi's cancel. We have 180 divided by 2, so this would be 90 degrees. Remember, from geometry, we have a couple of formulas here for finding arc length and area of a circle. To find the arc length, and we're talking about the distance, the length along an arc, and we would take the arc measure in degrees out of 360. That's what fraction of the circumference we're talking about. Take that fraction times the circumference of the circle. Remember, we have two different ways of finding circumference. We can take the diameter times pi, or we can take 2 times pi times r, the radius. And then for the area of a circle, we take pi times the radius squared. Now here we have a couple of new formulas still dealing with arc length and area of a circle. So here we have our arc length, and we're going to find that arc length by taking the radius of the circle times our angle, and this angle is measured in radians. And then here we're finding area. All right, to find the area we're going to take 1/2 times, again this is our radius. We'll take the radius squared, and then we're taking that times our angle. Again, this is in radians. So here we're going to find the length of this arc on our circle here. We're given that the radius is 3 meters and that our angle theta is pi over 4. So to find arc length, we take the radius times our angle. So we would take our radius of 3 times the angle, pi over 4. Now we can get an approximate answer here. We could plug that into our calculator. And we find the length of this arc is approximately 2.36 meters. Now we're looking at that same circle. This time we're going to find the area of the sector created by the angle, pi over 4. Again, our radius is 3 meters. So to find the area, we're going to take 1/2 times that radius squared, so that's 3 squared, times our angle, pi over 4. So we have 1/2 times 9 times pi over 4. And then that, again, we can plug into the calculator, get an approximate area of 3.53 square meters. Here we have a couple more formulas. First we're going to be looking at a formula to find the linear speed. Alright, so here's linear speed. And again, we're still using S as the arc length. And T here is time. Alright, so linear speed or angular speed, this is omega as our variable. Alright, and that's going to be the angular speed. Here is our angle in radians, and here is our time. Okay, so for a problem like this, a child is spinning a rock at the end of a 2-foot rope at a rate of 180 revolutions per minute. So we can find the angular speed as well as the linear speed of the rock when it is released. All right, so let's start off with the first part here. We're going to solve these in degrees. All right, because we can solve this 2 different directions. We could solve in degrees or in radians. So let's start off in degrees. First, to find the angular speed, we know that this is making 100 revolutions per minute. And we know that in degrees, that it's going to be 360 degrees per revolution. So if we multiply this out, the revolutions are going to cancel out. 180 times 360, we could find out that our angular speed in degrees would be 64,800 degrees per minute. Now, still working in degrees, if we're talking about the linear speed, then we're going to take the arc length and then we're going to divide that by time. All right, and we know that one revolution is going to be equal to the circumference, which is 2 times pi times r. Now in this case our radius is 2, so then that would give us a circumference of 4 pi per revolution. Now if we have 180 revolutions per minute and we are going 4 pi feet per revolution, then we could find that the linear speed is going to be 7,200 pi feet per minute. Now we're going to solve this same problem in radians. Again, we're still looking at 180 revolutions per minute. But when we're talking about radians, now instead of saying 360 degrees per revolution, now we're going to say it's 2 pi radians per revolution. So now when we multiply that out, again, revolutions cancel. 180 times 2 pi gives us 360 pi radians per minute. Now in terms of our linear speed, again we have our formula. V is equal to S over T. Now we know that our arc length is R times theta. Take that over our time. So we know that the radius is 2 feet and that our angle we just determined up here was 360 pi. And we're taking that over our time, and that's in 1 minute. So when we multiply that out, we get 720 pi feet per minute.